Hello everyone and welcome to the fifth part of the IP Fundamentals for Pro AV Professionals webinar series. My name is Tibor Fejes and I will be the host for this event, meaning I will be staying in the background monitoring the session and I will be watching out for your questions. Today our presenter is Gábor Kocsis, as in the previous four parts. So he put all this training material together. While we wait for some more people to join, I know people finish up their meetings a few minutes late, so they join late. So let me quickly go through my usual routine of talking about the housekeeping items. Firstly, depending on what type of device you're using, you will be able to see Gábor's webcam and his shared screen next to each other or on top of each other, and you can manually resize to make one or the other bigger. But if you're using two monitors, then you can actually distribute the webcam and the share screen on multiple displays, so you see both at the same time in the highest possible resolution. Secondly, since this is a webinar, all attendees are muted by default, but you can use the questions panel at any time during the webinar to send us your questions. If they come up at any time, you can also send your feedback. Whatever you feel like sharing, please use the questions panel. And at the end, we will have time for a live Q&A session, which means I will read the questions and Gábor is going to answer them. And lastly, I would like to assure everybody that this webinar is being recorded and you will receive an automatic follow-up email after the webinar ends. The server needs some time to render the recording, but 2 hours after the webinar ends, you will get an automatic email. And that email is going to contain a link to the recording, and it's going to stay on GoToWebinar server indefinitely until we decide to remove it, because we have a newer version of this material, or we think that it is no longer relevant. So those are the three things I want to share. So let's jump right into it. Gábor, the stage is yours.
Thank you, Tibor. Hello, everybody. As Tibor mentioned, so we're going to do part 5 of this 5-part series, and we kept one of the webcams on just for you to see. During this session, I'm going to actually show you the device user interface. I'm turning off right now, but in the next, in a couple of minutes, actually about 20 minutes, you're going to see that user interface again. So let's continue with the 5th part of this entire series. And it's a reminder to everybody that this is not a sales and marketing presentation. We're talking about the technical features, the network parameters only. And in today, we're going to actually look into the UBEX portfolio, something I mentioned in the previous session. We're going to look into some of the troubleshooting and network analysis details, how to actually set up a network communication in this particular device. Now, of course, in the previous part, I mentioned that there is something different. When we showed you a nice way to analyze communication in the Wings product portfolio, we used Wireshark and Excel to import data and show a nice pivot table. And I mentioned that UBEX is going to be a completely different story. Now, one of the complete different stories actually is some of the technical features that we decided to make mandatory or fix in the configuration. One of the things that we do is we use a tagged VLAN, and the other thing is that we're using link aggregation mandatorily, even though we may have actually one SFP plus connection only. About 95% or even more of our projects are actually linked 20 gig device projects, so the devices have 20 gigabit per second communication, so link aggregation is used in multiple cables, but there's a reason why we say we use it anyway, even if you only have one cable. So what our engineers actually did is they looked into how many possible issues you can have when cables breaking, a fiber optics termination, or the connection is wrong, or maybe it's unstable. And they realized that if they enable these functionalities and they make use of them, then the system will try and automatically recover. And many of the things, the tiny little details that could break, if you have, let's say, just a interface issue with a fiber optics cable, then you would have those tiny details that you would need an IT guy for. However, some of these functionalities like a tagged VLAN and the link aggregation itself, the LACP protocol, is almost self-recovering a little bit. So you don't actually need to go to tiny little details of what's going on. The device is trying to help you with that. So you need to focus on the actual physical issue, let's say a termination, a dirty termination connection on a fiber optics cable. So this is the reason why we do that. Now, the other thing, of course, we talked about in the previous sessions in part 1 and 3, I mentioned the importance of talking with the customer's IT departments. They are really an important group for our systems. And the first thing I mentioned is that when we go to a customer, the IT department must know everything what we do on their network, every little detail, so they know how to set it up and how to react to any changes. The other thing is that when we have let's say standard policies in the network, some of the functionalities may conflict with those policies. And in large networks, there are a lot of security and network management policies to keep the system running. And of course, another thing is it was nice to look at how Wireshark is performing on a Wing system, but that software is in most cases forbidden to use in large networks. Nobody wants somebody just go in and sniff and find out how their network communicates. Now, because of these basic reasons, we want to make sure that the IT guys know a few important details. First and foremost, in order for us to do what we do with this product portfolio and do all that high performance, we're using multiple MAC addresses. So this is one of the things that an IT guy would say, okay, I know what policy to modify for this particular connections. And the other thing is, of course, we use multicast groups. As we talked about the AV over IP, UDP packets in multicast groups is the best way to do actual video signal transmission into, let's say, video walls or multiple receiver concepts. And then, of course, we have the tagged VLAN number 286. We actually picked a number that is not close to any standard numbers like 10, 20, 50, 100, 200, and so on. So the 286 is somewhere between. That's typically not conflicting with anybody else's network. Now, what we actually do is our devices put a tag on the communication package. It's not the network switches that do that. And this is how we can actually ensure our communication to be easily troubleshooted. And of course, the mandatory link aggregation. Now, this you would understand if you talk to an IT guy and you say that, hey, link aggregation needs to be turned on, and you give them the specification, and they say, oh, you have one cable, what do you aggregate? Well, it's not actually an aggregation reason, it's the way how we ensure the quality and the performance. We actually help you troubleshoot the system easily by having the link aggregation technology try to recover if there's a connection problem. Now, these are the things that the IT guys, of course, find as unique details. And with this, of course, they will be able to help you along to build the system. Now, because I mentioned this Wireshark thing and the Excel importing the comma separated values, let me give you a bit of a detail. So it was easy that time, but it's not easy actually with the UBEX products. So I have a couple of capture files prepared for you. And we'll look into the Excel. If you go scroll down to the bottom, you see Excel has about 1,000,000 and like 48,000 rows, a little bit over that is the maximum limitation of Excel. Now with UBEX, actually, if you are trying to monitor or sniff, if you call the jargon, on the mirror port, then with a 10 gigabit connection, only one 10 gigabit connection, it takes about 6 seconds or less to fill that table. Then you create a capture file that's actually 100 megabytes or more, the comma separated value. Now, a couple of customers did ask if we have this functionality in other products. Let me tell you how we do it. So courtesy of HP EMEA, we have an HPZ for industrial workstation, but actually you might not have such a computer in your installation. So we can do such sniffing, but you may not be able. So what we're going to do today is, instead of focusing on that method, we're going to show you things that you will have available at the network site. Majority will be the network switches graphical user interface. Of course, we have the LDC software. And what you've seen in the other webcam, which I will turn back on later, is the LCD display of the UBEX device, where you can actually easily find, for example, how to recognize if link aggregation is set up correctly. Now, just to give you a kind of a visual, this is the example of when I created the 16-second monitoring of a UBEX communication, but I only used the 10 gigabit port. So, and that communication was a little over 10 gigabits per second between the two devices. And as you can see on the screen, I reached that maximum limit of Excel in about 5.5 seconds, 5.6 seconds to be exact. And actually, I had over 6% drop rate, which means that the network interface received more packets that it could manage. And even though I actually had that 3.3 million packets coming in, I did lose over 200,000. So in such a network, unless you have the proper devices and aggregated network interfaces in the computer, this kind of monitoring would be quite tricky because actually the data you received would be false because you're missing information that you might want to see. So that's not the way to actually analyze this data because we have, again, millions and millions of packets in 10, 15 seconds. Now, the other thing is, of course, the infrastructure. Now, as I mentioned, this is not a sales training. We're not talking about how many things and how many ways the UBEX can be configured. We're going to use the simplest way. One of the easy way is the extender mode when we have a transmitter and the receiver. And there's nothing in between. There's no infrastructure. It's just the cables and all the connection, the load balancing, link aggregation, everything they do themselves one-on-one. And we're going to use one of the gigabit Ethernet ports of the UBEX transmitter, for example. We connect and we can configure them. This is the easiest way, and it's not something we have a problem with. It's just cables, a pair of cables. Now, the other system is, of course, something called a matrix mode. Now, matrix mode cannot be set up manually. This is an automatically setting up system. When you connect the UBEX devices to a network switch, and it's going to actually, both devices are going to start looking for the MMU or the matrix management unit. Once they find each other, they're going to automatically go into this matrix mode. And so the MMU becomes the boss of that communication. What happens is the moment the MMU will present and the devices go into matrix mode, they will require that the configuration is going actually through the MMU. So you are going to communicate with your LDC software to this management unit, and the data will be shared with the transmitter and the receiver devices through the switch by the MMU itself. So technically, the connection goes the following way. So you have a simplest example of a transmitter and a receiver, and you get, let's say, 18 gigabits per second communication going on audio and video signals. And on the same connection, actually, the same 20 gig connection is where the MMU is tapping into the communication. Now, the MMU only has a gigabit port. Actually, we have an SFP and a gigabit Ethernet RJ45 connection because there is no high bandwidth data going through the MMU. So when you are connected to that, you can have control and configuration information going through that channel only. So it's going to be a fairly low use interface. Now, when you're configuring that device, you can do a couple of things. First is the easiest, more preferable way is when you connect the configuration computer to a control interface. An RJ45 connection, it's actually separated from the network. And when you connect it, it's just a one-on-one connection. We actually have two of them, one on the front and one on the back. And in a couple of slides later, I'm going to explain you why we need to focus on some of those. The other thing, actually, what I'm going to do today is I'm going to connect the same computer to the network switch, and I'm going to use the same connection that the MMU already has, and I'm going to send in the LDC or the GUI, actually the browser's graphical user interface surface, to communicate and send control commands to the MMU, which will be sent by the device to the actual UBEX products. Now, of course, there are other things, and I mentioned we're not going to go into the details of how many ports we have, but we do have gigabit Ethernet ports on the UBEX as well. And on these ports, we can actually connect end devices. This is a very important thing. If I connect, for example, a computer that does Lightware 3 protocol communication, then I can send it to, let's say, the other end. So the receiver can get control information transmitted by the device that was connected. The same computer, of course, can be connected directly to the network switch, and the information will find its destination. And of course, why we do this? Because if you have, let's say, LAN control-enabled devices like projectors, then somehow you need to send them information. And this is actually possible if you have that. Now, as you see in this connection, actually the devices, their gigabit Ethernet ports are not connected to network infrastructure equipment like network switches. And there's actually a reason. And that reason is a spider web of issues, something called a network loop. Now, a network loop can be generated by anything and anybody accidentally, especially in large rack systems when there's a lot of connections, and it would affect everyone. Some computers actually crash. Some computers slow down if this network loop happens. So you don't have to have a specific brand of or type of device on the network. A single loop will cause an issue. And so we need to focus on the network loop types. So what you see on the screen is a classic, simplest way of connecting a transmitter and the receiver, and they're going to connect to the 10 gigabit SFP plus ports, and two of them being actually aggregated. So if you accidentally connect, let's say, a gigabit Ethernet port, the RJ45 connection, to the switch and an endpoint connection, you just generated a network loop. So the device is going to be multiplying some of the packets. Of course, this happens on the other end as well. So it doesn't matter which device. An endpoint connection going back to the infrastructure will actually generate that loop. Now, of course, there are other cases when you accidentally connect through a patch cable the two devices, the two endpoints together. Now, this is, of course, it looks easy. Why would we do this with a piece of cable? You have a large system with a lot of patch panels. It's not actually that difficult to create something like this. In fact, you can actually create something like this as well, accidentally connecting the local end device ports as well. And that's actually a network switch inside. So you would actually connect, like it's the same way as you would take a network switch and you plug two switches and actually create a loop on a network switch. It's of course happening the same thing with the other device. So it's identical on both ends of the communication. And just to make sure we address this, when you do this, it doesn't matter if you use just a patch cable with patch panels. If you do that with a network switch and you accidentally connect them, the two ports, let's say, to the same switch, then you also generated a network loop. And of course, as it's logical, you can do the same thing when you connect two of the endpoints to the same switch. You can accidentally create the loop again. And this is when high traffic is going to be generated and the system will shut down. I'm going to show you how high traffic can be recognized on the network, actually. Now, of course, we have another device, the MMU itself. So with the MMU connection, the same logic happens because when we have the endpoint devices, the UBEX devices connected with those 20 gig aggregated links, there is the 1 gig connection of the MMU that is doing the communication. And that's the purple line there in the middle. Now, if you accidentally connect another port next to it, they are actually framed on the device saying UBEX network. That's actually the same connection. Now we have a purple line and a green line. There are two different sockets, and there's actually a reason for that to do this. We have a typical and even number of ports on the network switch, and if we have, let's say, enough UBEX devices to fill that switch, then we would need an extra port, one more, to the MMU. So we can actually do the same gigabit connection through an RJ45, and in this case, you would not need a second switch just to connect that device. So, but if you connect both of them on the same network, it's a network loop. Now, of course, the other thing is the two control interfaces. There's a switch inside the device for that as well. Even though they're separated from the infrastructure, when you connect those two together, there will be another network loop. And of course, when we follow the logic, if we accidentally connect this control network with the UBEX network, yet another, we're actually linking two networks together. That is a form of a loop, internal loop. And of course, not to mention that the end devices ports can accidentally be connected somehow if I use a patch panel to the control ports of the MMU in the front, or the same thing, of course, can happen in the back. So each and every one of these connections are possible with the if you create a loop. And so it's the easiest thing to remember is whenever you connect the gigabit Ethernet connections of the UBEX devices, they are not for the infrastructure, they are for end devices. So you should not connect them on switches, and you should not connect them back on the main device. So we have to make sure that we do not this kind of loop infrastructure. Now, actually, we're going to be very soon switching over to the other workstations. Let me show you what we're going to do. I'm going to show you different user interfaces, mostly focusing on the network switches interface to see how we create the configuration. And I'm going to also show you the LCD display of the UBEX device. And we're going to see how do we see actually the link aggregation connections being up, whether we have 10 or 20 gigabits per second connection, and whether the link aggregation is actually running. Now, with this, actually, what we're going to do is, so we're going to switch over to the other computer. So I'd like to ask Tibor to switch me over. And now you're actually going to see the other workstation. So one of the things I wanted to mention, because this has come up multiple times during this webinar series, and as well this morning with a question. Now, in order to configure a system like this, when we have the tagged VLAN mandatory with the 286 number, then we have all the UBEX devices and as well the management unit in this particular tagged VLAN. Now, if you have ever tried to do a tagged VLAN on a workstation, it's not exactly easy to do when the window's already at a computer. So when you would set up and you would try to put your laptop just simply into a tagged VLAN, it wouldn't work. The reason is because our devices are actually the ones that are putting the tag on the communication. So there's no mistake and you don't need to set up a lot of details device by device. And therefore, if you don't know how to set up a tagged communication on the laptop, you're just going to be wondering what happens. However, what you can do in a network switch, and actually you're going to see this configuration in a minute, you can actually put the MMU in also in another VLAN, which is an untagged VLAN, and the system is going to be VLAN 1. So my laptop and the MMU device are going to be in the same untagged VLAN, so you can actually communicate to them. So in this particular case, that then 1 gigabit Ethernet connection between the MMU and the switch will deliver tagged VLAN information for the UBEX devices, untagged information for the laptop. So let's go into it and let's see. First, what we're going to do is we're going to look into it as a reminder in our website in the download section. If you go to the application note and you type in network, 2 documentation will come up. One of them is actually the UBEX network setup guide. And this is the document that describes all the functionalities, all the steps you have to make to set up a network switch. And we have multiple types of network switches in the documentation, and we can actually see how to set up different types of network switches. Now, typical for this kind of documentation, and it's actually true for almost every network manufacturer's documentation, they say, please set up your features first and then connect the devices. So this is the same thing. The documentation guides you to step by step what to do with the configuration. And once you're done, you can connect everything. Now, of course, then you wouldn't see what the individual features do. So I'm going to break all these rules. And we're going to create a lot of problems on the interface just so you can see step by step what we're going to do. Especially because a documentation, we're showing the advanced user interface. In the Ubiquiti case, it's called legacy interface, which configures everything. Now, because Ubiquiti has a new graphical user interface that's for simpler, easier tasks, we have to make sure that we know which user interface we do. I'm going to make intentionally a couple of mistakes to see how we can configure the system wrong and why can be certain things illogical in the beginning. So let's go look into these user interfaces for a minute. And this is the Edge Magnet switches user interface. This is the classic. This is something you find in the documentation. And I'm going to click and also activate the new user interface, which is more graphical. We're going to actually use this to visualize the network communication. Now, what we see right now actually is the number of ports we have here physically connected. We have 4 white ports. These are 10 gig connections, so they are physically connected. There's no communication going on it. There's 1 green connection. This is the MMU actually. This is a 1 gig connection, an SFP connection. And over here, the port 15 is my workstation's gigabit Ethernet. I am configuring the switch right now through this port. So when we're looking into this interface, you can see that the UBEX transmitters port 1 and port 2 is here, and the receivers port 1 and 2 are here. And these are 10 gigabit connections, and we have the 1 gigabit connection down here. Now, as you can see, I turned almost every feature off, so we can actually start from the beginning. Now, right now down here, we have a mirror port. If we have some time at the end, I'm going to show you how we can capture a lot of data and lose a lot of data in this kind of connection. And down on the bottom, you can see my gigabit Ethernet port is communicating. This is because I'm connected to the switch with a TCP connection. So this is the data of me seeing the browser surface of the switch. So we're going to look into this and we see what the documentation say. Well, actually, the documentation starts with 2 steps, but I'm going to make it. I'm going to switch the configuration order to see if I can make a mistake, and I'm going to actually use this interface that's not designed for advanced features. First, the system says, please create a link aggregation, but I'm going to actually do the VLAN first. Now, the system says we have a tagged VLAN, it's mandatory. It did create the VLAN already, but is all ESO excluded. This means none of the ports are connected to this. So let me actually put all these ports into a tagged VLAN and see what happens. Now, you see up here in the default 1 is the port of the MMU device, and my computer are in the untagged default 1. This is what I mentioned with the slide, that this is the connection I'm communicating with. But now, the first and the second ports are the UBEX transmitter, and the third and the fourth in the UBEX receiver. And this port is the MMU. Okay, so let's create this tagging. Okay, so far so good. Now, there's not going to be really any connection. Okay, so let's see what kind of other thing we can do. I'm going to turn on my camera for a moment, and what you're going to see and very soon is the UBEX LCD displays coming up. So I'm going to go into the jog dial, and I'm going to go into the SFP1, which is actually port 1. And I'm going to say, let's create link aggregation number 1. Now the graphical user interface is simple, and we'll see what's happening. Now the link says it's up. Okay, so if the link is up and I have something like a 4 point something gigabits per second communication going on it. Okay, good. Now let's see the SFP2, which is not aggregated yet. It says waiting for aggregation. So let's go down to the bottom. In the meantime, you can see the bar coming up on the graphical user interface. I'm going to go to the bonding state, and what you can see is the bonding says LACP error, because this is the transmitter that needs the second port to be aggregated. And so my maximum bandwidth right now is 10 gigabits. Okay, so I'm going to stay on this screen because you've seen what happens on the interface part. I'm just going to click and aggregate to the second port as well. And very soon you're going to see the aggregation is okay. Now we have 20 gigs per second, and very soon you're going to see a bit of a change on the graphical user interface. You see that suddenly we don't just have 4.2 gigabits per second, it's going up, and it's actually going to be about 17 gigabits per second. Now, mind you that this number, when you see in network switches or in like advanced devices, a kind of a summary number like this, when you now see in a 10.9 gigabits in a 10 gigabit port, this is actually an averaging function inside the device, so we don't want to rely on these numbers. They are kind of averaging momentary numbers, and this is why it looks like there's communication. But right now I have, in reality, a lot of communication going on in the ports. Now, so let's see how much information is going on. We have 8.8 gigabits per second going on the second port, and it's 8.8 gigabits per second, by the way, on the other port. So we do have 17.6 gigabits right now running. Okay, so I'm going to keep up the screen to see if things can change, because there's a lot of LED flashing going on. So, okay, well, I do have the link aggregation. I do not have aggregation on the receiver yet. I'm going to just click them in. The receiver is next to me. It's the same thing that's going to happen. Okay, I have the aggregation going, and very soon we're going to see maybe some changes, maybe not. Well, there's a bit of an issue, actually. So the issue is that when you do this kind of things, the moment you aggregated something, the VLAN configuration differs. And I'm going to show you then the other way. Here, you don't actually see something called port channels. The moment you aggregate network cables, you're going to have to treat them together as one connection. And in the Ubiquiti world, it's called port channel, and it's configured the other way. So I'm going to actually turn off for a short time this user interface. I'm going to switch over to the user interface we recommend to use. Actually, it's important for us to use because everything is configured here. I'm going to go to the VLAN session and see what we did. And I had a timeout, so I'm going to log in again. Network switches do deliberately time out if you don't touch them for a while. So actually, we're going to go into the VLAN section and we'll look at what happened. What you're going to see is these gray blocks indicate that these ports are no longer treated as individual ones because they are now aggregated. And what happens is, I'm going to show you in the port channel part, I have a channel called 3.1, and I'm going to put a tag on it, and the 3.2 also going to put a tag on it. And I'm going to submit this change, and let me show you what we actually did. And this is when you're going to get used to a little bit of the network switches configuration. So what we did actually, and let me save the configuration just for good luck's sake. I'm going to go into the port channel or link aggregation part, and what it says is this 3.1 interface is actually a virtual interface in numeric logic, and it has members 1 and 2. 0, 1, and 0, 2 are the physical 1 and 2 ports on the switch, and 3.2 is the logical number that actually has members of 3 and 4, which are the physical links 3 and 4. So now if this is done now, actually we might have some changes. Now I look over and I see that all LEDs are flashing rapidly, which means I have actually 5 interfaces that have very high communication. Now let's verify this and go to the graphical user interface. Now you see there are 5 ports, but I only dealt with 4, right? So is it right? Well, sort of, because here I have a lot of communication going with the transceiver and a lot of communication on the receiver. A side note, if you haven't used managed switches before, it looks opposite because the network switch says I'm receiving this much information from this device and I'm transmitting this much information to this device. Now here's we have actually a problem, and the problem is right here. Down here, this is a 1 gigabit per second interface, and I have 1 gigabit traffic on it. What happened is, of course, I only did 2 features, and the third and the fourth needs to be set up later. Actually, it's the next step that is 2 different steps. That's the IGMP snooping. So right now, the multicast information that is going 17.6 gigabits per second of multicast information is being sent to every connection because the IGMP snooping is turned off, which means that a gigabit Ethernet connection is right now receiving a gigabit of information that it doesn't need. And that's why if you would, let's say, try to communicate to this device with the software, then you would not be able to. So if you go to the device software, you may actually see the device sometimes because it does send actually information, but when you try to communicate to it, it actually might work, but most cases, 99% of the cases, is going to fail. And the failure now actually succeeded. We just got a little bit of traffic, a few packets, but this is going to be slow, and it's not the device and not the application that's slow. What happens is it is receiving almost 1 gigabit per second of information, and in the meantime, we lost connection. So the device works fine, but this 1 gigabit of information that it doesn't need is what it's breaking it. So let's go and follow the documentation, and let's see how IGMP snooping is set up. We're going to go to the switching, and I'm going to turn on the snooping part. And the first step is to say in this system, in the Ubiquiti world, admin mode, to be able to actually configure the parameters. Let's submit the change, and very soon it's going to be a safe configuration. We can actually change multiple things, and we're going to save the configuration later. I'm going to go to the interface communication, and the documentation says, please set up IGMP snooping in every port. We're going to do this, but remember, port 1, 2, 3, and 4 are aggregated into 2 groups. So 3.1 aggregates port 1 and 2, and 3.2 aggregates port 3 and 4. So now what we need to do, according to the documentation, is to edit, enable the admin mode, so we can configure, look at these default parameters, and turn on the fast leave admin mode. I'm going to submit this change. And when we see all the ports actually enabled and both enabled, that's fine. We can actually refresh sometimes to validate if the changes are taken. There's a reason why the network switch manufacturers say, please do not connect the device while you're configuring. Sometimes it can cause troubles, but most cases it's okay. But just for the test sake, just for troubleshooting sake, I'm breaking those rules. Now, the third thing, actually, what we need to do is something called a per VLAN setup. So IGMP snooping inside a VLAN. The documentation says, please put in the tagged VLAN 286. This is what I'm going to do. And I'm going to select the 286. I'm going to make sure that the user interface refreshes and make sure that this is enabling those details. And there's this report suppression is something we don't need. That's more of an advanced thing. And I'm going to submit the changes. So if I have this enabled, so I have the fast leave admin mode enabled, I'm going to actually save the configuration. And I'm going to go back and actually going to validate all the parameters. So it's all enabled, fine, no changes. I'm going to go back to the interface and see, yes, all the features were enabled and actually saved. I'm going to go back to the main configuration and say, yeah, it's enabled. Okay, let's go back to the graphical user interface and see what happens. Now, of course, the bar already gives you the information that there are a lot of details are going in, control messages, by the way, from the transmitter, and there's a lot of information going to the receiver. Remember, these are average numbers. They are not representing the actual network number. However, down here, the averaging is going down and down because now IGMP snooping knows that the messages coming from the transmitter are UDP multicast messages that should not be received by port 5. And this is actually how we just fixed the network communication issue. So now the MMU does not have actual network communication problems. So I'm going to do is I'm going to restart the interface, and I can see that I have devices that are connected. So I'm inside the MMU, and I can actually do diagnostics on the device and see, yeah, okay, there are communication, and the network switch is coming up. It's kind of communicating, and we see, yeah, the LLDP information is coming up. So this is actually what we did, and now we can see that the communication is going on. And this is one of the things that it's important for us to remember. If we are setting up a device like this, then we have right now really 17.6 gigabits per second coming out of the transmitter, and we have about the same amount of information going into the receiver. Down here, because this is a configuration interface, it's not receiving, and it's not supposed to receive any more than a few kilobits per second on the configuration. This is actually what we need to make sure we understand. I'm going to go into the LDC software and see if I refresh this. I go into, depends on your current network situation, you may have actually something that you could lose, but in general now, because the network connection is fine, then we can generate some test. Now in this interface, I can do diagnostics and I can look into the interface, and I'm going to actually see if I can generate a couple of problems for you. And I'm going to show you how to recognize in this interface. I'm going to go to the network switch. I'm going to go to just the graphical user interface and see, okay, VLAN is fine, but let me ruin the link aggregation. And you've seen on the LCD device, and we can actually see going into the LCD and the link status, and I'm going to see SFP1. You can see, by the way, in the LED that the MMU available is steady, so the communication is fine. I'm going to take link aggregation 1 out, and the LCD you're going to see is status up. It's going to be waiting for aggregation. And let's see if we can actually do one of this. Let me refresh the screen, and we see if I have very soon an issue. Now on this surface, you can see an orange thing. The orange is because it says that the two ports, the two communication that I'm doing is actually doesn't have enough bandwidth. So right now, because I have a link aggregation problem, I no longer have 20 gigabits per second for a 17.6 gigabits communication. So what happens is when I go to the stream information, I can see that I'm trying to send 492 by 2060 at 60 frames per second, and there's no conversion. Now, of course, if I'd say, yeah, just for the sake of this training, I'm just going to go all the way down the lowest. Now, actually, those problems gone away. Now, we're, of course, not going to troubleshoot the whole thing. I'm just going to show you how it happens. When we have this low resolution, my bandwidth is no longer a problem. Let me go back to the highest, and now the bandwidth is going to be a problem again. So if I go and look into some of the other device properties, I can see that I have a communication issue sometimes. And because I have a forced 13.76 screen, that's a full resolution, and I'm going to go all the way to that bottom and 640 by 480, and suddenly I have a half a gigabit. So guess what? A half a gigabit of information isn't a problem, but the fact is that we don't have a link aggregation set up. We have no communication on the cable. So what happens is now when you see this, actually can refresh with the screen. If I fix the link aggregation, I'm going to go back in the network switch, and I'm going to actually go and put it in line 1. On the LCD display, very soon the link's going to say up, and when it's up, then it's fine, and I'm going to actually go all the way to the bottom, look at the bombing state status, and we see it's total of 20 gigs. Now, as you can see, the device has to reset and do some of this communication. Now, of course, again, when I'm doing forbidden things like a network switch requires me to configure these things and don't mess around with the different user interfaces is why actually I can break things. So in a typical case, when you do something like this, the recommended thing is, as the manufacturer's request, configure everything, then connect them. Actually, as the configuration, sometimes you just do a power cycle, you reboot the system, so let it start up with the proper communication. Because right now, I actually intentionally broke things by using different user interfaces, and I broke the rules of how a network switch is supposed to be connected. So now my 4.2 gigabits per second information is going through one port. There's no reception on the other end, and there is no MMU. However, with different user interfaces, now as you see what happens, we can actually understand from here that, okay, he's talking, he's not receiving, and there is no communication here. So we might have an issue. Now, let's do a little bit of a play because we have a few more minutes, and I don't see any questions coming up yet, which is typical for these webinars. So let me actually show you the network capture. So I'm going to turn off these applications, all of them, and I'm going to show you what happens when I have the Wireshark application. and I'm going to show you how much of a powerful computer you need. Now, previously, and it may be actually difficult to see, I did do a capture. That was the 6.2 million packets received, 6.5 million packets lost. It's a 542 megabyte capture file. So only half the information was going on. So what I'm going to do is I'm going to physically connect the interface on interface 7, and we're going to see if there is a communication going on. We can go into the graphical user interface back in the switch and see what happens on that port. Because there could be a case that you don't enable the port mirroring function, but we can see that my information is actually getting all that 4.3 gigabits per second. I did this kind of trick because if I start showing you 17 gigabits per second, it's going to be a lot of packets, so it's going to be almost impossible to see that. So I do have the mirror port functionality set up correctly. So let's play around and see the computer's performance. Ethernet 7 is where we have the communication. Let's do that little capture. In the capture mode, I have to actually, because of this, have a special option and make sure that I do not update the packets in the screen and I'm not scrolling, because there's hundreds of thousands of packets. What I'm going to do is this small capture window is going to come up and it's going to start showing what I'm doing. So now it starts sending a lot of messages, and I have now over 1 million packets right now, and I'm going to stop the capture. Now the computer, if you see this, the computer didn't go up to more than 30% CPU use, and the memory was fine with this 17%. This is why you need a very powerful computer. And the network switch did actually go up to a pretty high number. Now, here's the capture screen, and let me show you what's inside. I'm going to scroll all the way down to the bottom to show you that I captured 1.7 million packages in 7.1 seconds. And I actually lost 71% of the packets. 1.2 million packets were lost because I have two aggregated ports and I was not able to actually capture all the information going on. So as a final thing, something that you've seen in the previous part, I've shown you this graphical analysis. And actually, it's going to take some time for the application. And you see that the CPU is not really breaking a sweat with 30% of functionality. The memory barely moved to 20%. But the software application is actually pushing this green bar and trying to create that. So this actually may have a complication for you to create this kind of interface analysis, because right now the application is really trying to capture or actually visualize 1.7 million packets. So this is where the computer power is really important. If you do this, you need to make sure that you understand that we have easily overshot the limitation of the Excel, for example. So whatever I capture, when I export it to the comma separated value, I'm going to try and reset the graphics, so you can see that even the software sometimes struggles to handle 1.7 million packets. And if I would like to do, say, save it as an export as a comma separated value, I'm going to call it C and save it. It's going to actually start pushing the bar all the way down here, the green bar. It's trying to save the file. And as a final thing, I'm going to actually go look at the C of comma separated value, and we see the file size. Computer is still on 26% to doing this. And when it's done, I'm going to go into the documents, and we have the C 171 megabyte file. It's not, of course, a surprise, because I deliberately reduced the size of the packets in the transmission, but the number of packets, of course, still a lot. So imagine if your computer is trying to open, and here's the other file I created, 624 megabyte comma separated value file. If you have a computer that cannot do this capture and it cannot open that file, then you might not be set up to actually do an analysis in here. And of course, as I mentioned, Excel has a little over 1 million packets. So if I would go and roll up a little bit to see where's the 1 million row is, somewhere around 4.2 seconds. Well, yeah, somewhere around 4.25 seconds, we overshot the limitation of Excel. So, and with this, I'd like to hand the control over back to Tibor, and let's see if you guys have questions.
Not yet, as usual.
As usual.
But, this is the time when people start grabbing their keyboards. So, yeah, we hope that this part about UBEX and all the 5 parts, if you watched all of them, were informational and you learned some things, or you found some things interesting. This isn't something we've done before, to go that deep technically with Wings and UBEX, but Gabor actually sat down with the support engineers and he asked them what are the typical problems that people face during the installations, and most of those things that they mentioned are in this material. So hopefully by doing this training, we made your job easier and we made our job easier as well. We hopefully lifted some burden off the support guys' shoulders. Hopefully the company's IT administrators as well. And hopefully you will speak their language a bit more in the future by understanding how AV over IP devices work, both on 1 gigabit Ethernet networks and 10 gigabit Ethernet networks. So yeah, no questions are coming in. All of the attendees' brains are frozen, I guess.
Okay.
So
let me freeze their brain in the meantime, because we had some interesting questions in the morning session. There's actually a reason why I put up the VLAN setup. The question was if they have also a Wings product portfolio on the same switch for some reason, would it be a problem? And how would the communication go? So, would it be a problem? And the answer is no, because when you've seen in last week's configuration setup, Wings requires a VLAN, but it does not require tagged VLAN. So if you have this connection, I have, let's say, only 1 gigabit Ethernet port used by my laptop. So I could technically connect 2 other devices, like 2 Wings, for example, port 7 and 8. What I could do is I would go in and I would say, create a new VLAN, let's say 123. And I would say in the 123 VLAN, I would say untag, apply, and done. And now in this VLAN would be the Wings devices. They do not communicate cross with the 286, and they do not cross communicate with the computer. Now, of course, there is one thing we mentioned, is you cannot set the same physical port into more than 1 untagged VLANs. So if you would like to configure, what you would do is you would actually have 1 free port connected here. So the 2 Wings products would be here. You would connect your computer. You would be able to program the Wings products. And if you plug the computer into this here, then you would be able to configure the MMU for the UBEX devices, while the UBEX devices with the MMU would talk in VLAN 286. So these VLANs actually completely separate the network. And the question was if we are actually separating unicast, because we've seen in Wings that there's unicast messages going when we're sending a file. So between, let's see, a receiver and the decoder and the encoder, when I connected a storage device and I have moved a file over the Wings connection, that's a unicast. But remember, VLAN separates everything. Unicast, broadcast, multicast. It's like you would have physically different switches. So, and actually I generated this VLAN, and in the meantime on the display, you see that the link aggregation didn't change. We have 20 gigabits per second. The MMU LED on the bottom is on. There was no effect of actually adding any more VLANs. Of course, they have no connection right now, but this does not, these VLANs do not impact each other. That's actually the whole purpose, something we went through in part 2 and 3.
Still no more questions, so I'll start wrapping up. Thank you for everyone who joined us today, and especially thank you if you joined us for all 5 sessions. We know that we were asking for a lot of your time, but hopefully it was worth it. If you would like to learn more about Wings or UBEX, then feel free to go to our website, www.lightware.com. And if you don't find what you're looking for there, please feel free to reach out to us, either your local Lightware representative, or write us an email to support@lightware.com, or in training related stuff, you can write to training@lightware.com, and Gabor reads those questions, so he will be able to respond to you directly. You can also get demo units. Unfortunately, because of this COVID situation, we cannot organize demos at your site, and we cannot invite you to our own offices, but we can send you demo units, either Wings or UBEX, Actually, when the broadcast ends, you will be prompted to fill out a survey, and one of the questions in the survey actually asks you whether you would like to receive a demo unit. Just tick any of those options. If you would like to get a demo unit for a few weeks to play with them, just decide whether you want to use it or whether you can use it in your future products or not. And if you have an opinion about the features, the ports, the capabilities, then we would welcome those ideas as well. So thank you very much, Gabor, for putting this material together, especially in such a short time period. So I don't know when you started, a few weeks ago maybe, but
close to it, yes.
You have a lot of experience in IP, so you could be quite quick in it. Yeah, just a few thank you messages. Thank you. Your words mean a lot to us. I think that's it for now. We will let you go a few minutes earlier. Again, thank you very much for joining, and we hope to see you in our future webinars. And until then, stay safe.